Hi, this is Benjamin Butler, and I'm submitting my exam correction for the last exam. I don't know, was it exam 4, I believe. The first one I missed was number 2, which stated two parallel wires are near each other and they carry currents in the same direction. Wire 1 carries current I and wire 2 carries current I. Which statement about the magnetic forces that the two wires exert on each other is correct? My original answer was F. Wire 2 exerts a stronger force on wire 1 than wire 1 exerts on wire 2, and they attract each other. The correct answer is B. The two wires exert attractive forces of the same magnitude on each other. So I understood that they were going to attract each other because they were going in the same direction. The mistake that I made was essentially, I think, separating their forces when with the equation the force equals mu naught. I don't know if you can see that, mu naught times the length I1, I2. So essentially in this entire equation you have one force that's being calculated, which would make sense that it would then be B, and where they exert the same magnitude on each other. It's one force with two wires. So that's number 2, and I understand why that is B now. The next one I missed was number 9, which states two straight parallel wires are separated by 6 centimeters. There's a 2 amp current flowing in the first wire. The magnetic field is found to be 0 between the two wires at a distance of 2.2 centimeters from the first wire. What is the magnitude and direction of the current in the second wire? And my understanding of the equations and of the problem was, well, I should say my understanding of the equations was not at fault. I did not fully read the problem, which I'm discovering is a theme of mine, where I need to slow down and read these questions more thoroughly. So essentially the mistake I made is in the middle. If the magnetic field strength is found to be 0 between, I misinterpreted the question and thought that it was 2.2 centimeters out from the first wire, or a total of 8.2 centimeters away from the first wire, when in essence, if it's between those two wires, it's not desiring what the force is at 8.2 centimeters. It would be in between, which would be 3.8 centimeters. And if I take that into account and essentially use my exact same equation but with the correct radius, I get the correct answer of 3.5 amps instead of 7.4. That is the only thing that was the mistake in that question. Yeah. Okay, the next one I missed was number 10. A 40 centimeter long solenoid, 1.35 centimeters in diameter, is to produce a field. How much current through the solenoid carry if it has 765 turns of wire? Same problem. I did not fully read the problem. I completely omitted that there were 765 turns of wire and thought I had to come up with my own length of wire, and completely had an erroneous answer for what the number of turns of wire would be, and it was given in the problem. A complete bonehead mistake. Again, my equation that I used for the solenoid, mu naught, number of turns, current of the wire divided by the length. All I have to do is plug in those, what's given, including 765, not 29.6, which I thought I had to come up with that, and I was thinking length of the wire, times the diameter, but that would be the diameter of each piece of wire, and that's not given, so that was completely a mistake, and it was given anyway. So plugging in 765 turns, I get 16 amps, which is the correct answer. My original answer was 4.1, which is incorrect. The next one I missed was number 11, and a 25 ohm resistor and a coil are connected in series with a 6-volt battery. At 3.3 milliseconds after the switch is open, the current has decreased to 0.21 amps. Calculate the inductance of the coil. And I made the same sort of mistake. So, like, this is my correction for number 11, and I did not read the question correctly, because the key phrase after the switch is open, the current has decreased to 0.21 amps, so it is discharging, and I used the charging equation to attempt that problem, which is incorrect. So I originally tried to use the charging equation, and if I had simply plugged into the discharging equation, everything lines up nicely, and I get the correct answer of 0.6118 Henrys for that inductance, which is what was being asked for in the question. So 3 problems in a row that I did not read the problems thoroughly enough. I was rushed. The next one I missed was number 12, and I'm just... I couldn't figure out how to get from what I had, the magnetic flux equals B dot A, or the changing magnetic field, the integral of B dot dA, and I just struggled, and I could not come up with how to get that 0.245 meters squared being the original answer, and I struggled with that one, and I even after having the answer in front of me, I still couldn't figure out exactly how to get it. So I guess I'm only submitting 3 of those, or I should say 4 of those 5 corrections. So that's it. Again, this is Benjamin Butler, and these are my corrections for the last exam, which I believe was exam 4. Thanks.